Hey guys, this video I'm going to answer that million-dollar question for you. Why do we even care about transformations, right? Why is Mr. Bowers even putting us through all this geometry? I don't quite understand it. The reason, guys, is it's about orientation and about understanding congruence in shapes. Symmetry is how we can explain congruency, right? We're starting to see equal halves as we talk reflections. And as we rotate, we can understand, I hope, that shapes, no matter even if they're rotated, are going to have the same segments or same side lengths and angles. Nothing changes, just the orientation of the figure changes. And by the way, just congruence, that's just what it means. Same or equal, equal area. We'll talk about area later. But same, side lengths and same angles. Um, so, what do we need for each transformation? And let's talk about like reflections, for example. What we need to reflect is just a line of reflection, and we have these properties that I've been asking you to think about as we reflect, that we have points that are getting reflected are that same distance away, which means, points that are closer to the line of reflection, the orientation gets flipped, right? Because we have that equal distant concept going on. Okay, same deal here. Points that are further away will be further away when they get reflected, which is that orientation flip. We can see that as we reflect, the object gets flipped, right? That's the orientation of a shape after we reflect it. When we rotate, we need a center of rotation and we need an angle of rotation, right? So if we have a center, like this point right here, we can take a shape and we can rotate it some angle, right? Take that shape and just rotate it. But notice the orientation is different than reflections. It's not flipped, right? Wouldn't the point of this rocket be pointing the other direction if it was a reflection? So the orientation is a rotated image, right? So we have to be able to understand the difference between reflections and rotations. Same deal with translations. We need vectors to translate. The vectors are just our visual understanding of how a shape is sliding, but the orientation doesn't change. It just slides. It just goes to a different position on a plane. So the combination of these three can help us explain a whole lot of geometry when we just look at a shape. Okay, and I'm going to lead you through some quests where it's going to help us understand what we call coordinate geometry. How can we can use scale to help us understand and reason for us. So just again to talk about orientation, here's Mr. Incredible here. So if I reflect Mr. Incredible, we need a line of reflection, right? And we have that perpendicular equidistant property going on here. We got a flipped orientation, right? Even if they're on the line, they just be on the same place in our plane here. Okay, but reflections give us that that flipped look. Right, we have rotations. So if we have a center of rotation, we can rotate an image. It's different than reflections, right? Notice the reflection, even if I try to get them in about the same spot, notice reflections are different. We have Mr. Incredible's big hand here is, let's see if I can get this. Notice they're on different sides of the rotation and reflection. Okay, so just pay attention to the orientation, be able to identify if a shape's been reflected, rotated, right? I can change the angle, okay? Any kind of rotation here. Or if we translate, okay, there's some vector, right, that translates. So if I change the vector, I change the translation, the explanation of how an object shifts, right, vertically and horizontally. So just be able to be aware of the orientation, know when an object has been flipped, reflected, know when it's been rotated, and know when it's been translated. Right, and kind of see the three different kind of effects of what we can do to Mr. Incredible. So this helps us understand how we can move images around a plane and do animation. So good luck, guys.